Rethinking the Goldilocks zone, astronomers may have been looking for life in the wrong places.
For decades, the search for life on other planets followed a fairly simple rule: find worlds located in the so-called habitable zone, also known as the Goldilocks zone.
This is the region around a star where the temperature allows water to exist in liquid form on the planet's surface, neither too hot to evaporate everything, nor too cold to freeze. In our solar system, this zone extends approximately from Earth's orbit to near Mars. This concept has guided almost all the search for habitable exoplanets, but a new study, published in the Astrophysical Journal by astrophysicist Amri Wandel of the Hebrew University of Jerusalem, suggests that this traditional view may be too limited. With the increasing discovery of exoplanets, many of them orbiting stars very different from the Sun, such as small, cool red dwarfs, M-type, and orange dwarfs, K-type, it has become clear that the old model does not explain everything that modern telescopes are revealing. The problem lies in treating the habitable zone as a rigid boundary. In reality, the distribution of heat on a planet is more complex and flexible than previously thought. One of the most interesting cases involves tidally locked planets, those that always show the same face to the star, like the Moon does to Earth. In these worlds, one side remains eternally illuminated and hot, while the other remains in total darkness and icy. Previously, it was thought that this extreme condition would make the presence of stable liquid water almost impossible.
However, detailed climate models show that heat from the day side can spread through the atmosphere and warm parts of the night hemisphere. In some regions of the dark side, the temperature can stay above freezing, allowing water to remain liquid. This means that planets orbiting much closer to their stars' positions that the classical model would consider too hot may still have conditions for liquid water, especially in the cold, protected areas. Recent observations from the James Webb Space Telescope reinforce this idea, detecting water vapor and other gases in the atmospheres of super-Earths near red dwarfs, worlds that were previously ruled out. Another surprising possibility appears on planets beyond the outer limit of the traditional zone. That is, very distant and cold. Even on these icy worlds, liquid water can survive hidden under thick layers of ice, forming interglacial lakes or melted pockets in the interior. This is similar to what is speculated about moons like Europa, of Jupiter, where subsurface oceans may exist thanks to internal heating caused by gravity. This subsurface extension greatly expands the range of places where life could develop, without directly depending on starlight on the surface. By rethinking the limits of the habitable zone and including these mechanisms of atmospheric heat transfer and internal processes, the study shows that many planets previously classified as inhospitable may, in fact, offer conditions for liquid water and potentially for life. This considerably increases the number of candidates deserving attention in the search for extraterrestrial life.
The main message is clear. Perhaps we have spent too much time focusing only on planets with conditions similar to Earth's, ignoring very different environments, such as indirectly heated night faces or oceans hidden beneath ice. With increasingly powerful telescopes, such as the James Webb, the time has come to look at these unlikely places with new eyes. The search for life in the universe may only be beginning to explore the true corners where it could exist.